Hi guys, you're welcome to God Academy. In this lesson, I'll be taking you through the polar representation of complex numbers. In our previous lesson, I took you through complex conjugates and also we looked at modulus and arguments in the previous lessons. We continue with polar representation. We're going to make use of what we call the Euler's number E very much in this video. So I'll have this. So complex number z can simply be represented as e to the power I theta. Okay. Now when I say e to the power I theta, in the Euler's representation is simply the same as cos theta plus I sin theta. Okay. So if I have e to the power I n theta is the same as cos n theta plus I sin n theta. As simple as that. Now for us to represent our complex number in polar representation, we need two things. We need the modulus, which is represented as r. We need the argument, which is represented as what? Theta, right? So now you realize that we simply write re to the power I theta. Okay, so our r is here as our modulus and our theta up. That is z. Okay, so z is always represented as this. This is also the same as r cos theta plus I r sin what? Theta. That is all. So this is the idea of the polar representation of complex numbers. We also have extended arguments where our theta will be extended re to the power I. Our theta is now simply theta plus 2 pi theta. Sorry, 2 pi x or 2 pi k. Okay, depending on any unknown you choose. You appreciate this very soon. So just have in mind that e to the power I theta is always given as cos theta plus I sin theta. When you add n to it, it's simply multiplying here. We will look at the Morris theorem also in our next tutorial. So modulus is equal to r, argument is equal to theta, right? Then we simply represent. So this is actually the polar representation of complex number. Z is equal to r e to the power I theta. You can break it down to get your trig form. Now let's do multiplication and division. Multiplication and division of polar form of complex number in the polar form. Okay, so given two complex numbers, okay, if I have any two complex numbers z1 given as r1 e to the power I theta 1, z2 given as r2 e to the power I theta 2, then my z1 z2 is simply equal to, whenever you are multiplying two complex numbers in the polar representation, you multiply the r's. That is, you are going to multiply your modulus. So my r1 will multiply r2, right, like this. Then the powers you add, okay, you have e to the power I open bracket theta 1 plus theta 2. It's as simple as possible. So this is how we do it all the time. Okay, so my z1 z2 is simply equal to r1 r2 cos the angle theta 1 plus theta 2, then plus I sin r1, sorry, so this side, let me clean it and write it well. So plus r1 r2 sin I theta, oh I, sorry, the I will come here. Okay, so you have cos theta 1 plus theta 2. For the division, if you have z1 over z2, you are simply going to have my r1 e I theta 1 over r2 e I theta 2, and this gives me r1 over r2 by indices e I theta 1 minus theta 2, where in the polar form, trig form, I'll have r1 over r2 open bracket cos theta 1 minus theta 2 minus I sin theta 1 minus theta 2. As simple as that. We'll be solving more problems using all this. Now we dealt in with variables. See you in the next lesson as we go deeper into complex numbers.